Hey guys, welcome back. So today we will be doing operators and decision making statements. So we have many operators: arithmetic, relational, bitwise, logical. So right now we have arithmetic operators, and we'll be doing one program for it. And I'll be showing you the rest of the operators. So arithmetic operators are basic operators like addition, subtraction, multiplication, division. So for modulus you will be getting the remainder right when you divide. So when you use modulus operator, your answer would be the remainder. And we have increment and decrement. So increment is, as you can see, it is plus plus a plus plus. So your value would get incremented by 1, and when it comes to decrement, it gets decremented by 1 value. You use these a lot in your for and conditional statements. So let's go to our program. So basically, we'll use header files here, right? So for mathematical operations, we'll be using math.h as well. So math.h header file contains all these addition, subtraction, and operations of that sorts. So you'll be using that. So let me start typing my code. stdio.h for input output, and I'll be declaring hash include math.h header file, and let's begin with our void function, main function, not void. The return type of main is void. So yep, and here we go. So I shall be declaring two variables a and b as integers. So my value for a is 20 and my value for b is 5, and I have taken another variable to store my value once I've done the operations. So let's begin with our print statement, and our very first operation is addition. So let me add, and yep, so I give c equal to a plus b, and similarly you will be doing the same for all the other operations as well. For subtraction you use minus, and for multiplication you'll be using asterisk, and division is slash, and modulus, as I've told you, it gives the remainder when you divide a value, and the remainder would be the value of modulus. So let's go on with the program. So I'll be printing my print statements. Yep, and this is a star b multiplication, and we terminate with semicolon. And yeah, so now we've got our division done. So again, all these operators are very much used in C. You use it each and everywhere possible, and these are tokens as well, as mentioned in the previous videos. And our final print statement for modulus, that is remainder. And here we go, %d, our format specifier, and a mod b, and terminate it. And now let us so c equal to a mod b. For mod you give percentage as your symbol, and let's execute our code. So you've got it in a very straight line. So let me give my slashes here so it doesn't look shabby. So what you remember that we've used it to make into a new line, to get the output in a new line. This is quite important. We even have slash t as well. Let's check our output. So now we've got relational operators. So our very first relational operator is assign equal to, and if it checks if the operand A is equal to operand B, and if it is not equal, it gives false, which is 0. And then we have greater than if 5 is greater. In the example, as you can see, if 5 is greater than 3, it's true, hence 1. Less than, it's false. So, and not equal to would be yes, it is not equal to, and hence it's evaluated to 1. And then we've got greater than or equal to. So 5 is greater than or equal to 3. Yes, that's true. So you get true value, which is 1. And less than or equal to, so it's false, you get false. So relational operators do check the relation between the two operands given to them, and this is how relational operators perform their operations. And now we've got assignment operators. So it now in the very first operator is equal to. So in here, the value of A is assigned with the value of B, which means the value of B is given to A, and then we have plus equal to, and as you can see here, A plus equal to B, which exactly means A equal to A plus B. Similarly, you have A minus equal to B, which is A equal to A minus B, and we have A star multiplication equal to B, exactly same as A star B, and division also the same, and modulus operator is also used as the same. So these are different ways to assign a value to a variable, and they are very much used in most of the programs. You will see them further. So now, yes, logical operators, very interesting operators. So we've got ampersand symbol, as you've seen before. So here ampersand will give you AND. It's called logical AND. And if you can see in the example beside, so you've got expression 1 and logical and expression 2. So your value for this is going to be equal to true if and only if both the expressions are true. So in the example, A is equal to 5, that's true, and D is greater than 5. 2 is greater than 5? No, it's false. Hence your entire expression is false. And now let's come to logical OR. So in OR, logical OR, as you know, it's either A or B. If either of them is true, your complete answer is going to be true. So, and the operator for OR is this, and in the example, as you can see, it's the same example, and we already know that one of the expression is true. Hence, it's going to be, the entire expression is going to be equal to true. And logical NOT. So logical NOT is nothing but if your value or your expression is true, logical NOT will just make it false. Coming to our bitwise operators, these are bitwise operators. So bitwise operators are the operators which perform an operation on each and every bit possible, and it's called bit by bit operation. So hence it's called bitwise operator. So we've got AND here. So when you're given two numbers, suppose A is 0, 0, 0 and B is 0, 0, 1, when we use our logical AND, so 0, each and every bit of A is compared to bit of B, and if both are 0, it's going to be 0, and if both are 1, it's going to be 1, or if it's 0, 1 or 1, 0, it's going to be 0, right? So this is how AND works. Therefore, this is how AND works, and let's see OR. OR is similar to logical OR as well. 0, 0 is going to be 0. 0, 1, 1, 0, 1, 1 is going to be 1 because either of them is true. Your entire value is going to be true. And the operation is performed on each and every bit. We even have exclusive OR and complement, where ones become zeros and zeros become 1. And here we have an interesting operation called right shift and shift right and shift left. So it basically shifts to the particular number it is given. So basically you will give the operator and the number you want to shift to, or number of times you want to shift, or number of places. So it will shift that many places towards your left or that many places towards your right. So this is how bitwise operators work, and you'll be using them in many loops as well. Let us now enter our decision making statements. Our very first decision making statement is if condition. So let's see the flowchart for if. So this is the flowchart for if, and we have the condition here. And if my condition is true, the conditional code which is here will be executed. If my given condition is false, it just comes out of the statement and stops right there. So we'll have many ifs. We have if, we have else if, and we have if else if, and nested ifs. So we'll be using a lot of them further. So right now we'll be doing basic if and if else. So let's get on to the program right away. And here we go, my header files and stdio.h and my main function as well. So let me give my in this program I'll be checking if the number is even or not, and I've given n and s is my integers, n to take the number, read the number from the user, and s to check if it's even or not. If a number is divisible by 2, it means it's even, which means if a number is divisible by 2 and its remainder is 0, it is an even number. So that's what we'll be doing right here. So we'll be giving s equal to n mod 2, which means s will have the value of the remainder when n is divided by 2. If that is equal to 0, it means your entered number is even. So let's give our if condition, which is if s is double equal to 0, if s is equal to 0, and printf it is even. Let's execute it. Yep, let me enter the number, and yes, it is even. And now let's see else. The only other possibility for this is s is not being equal to 0. So you don't have to type that, so you give else directly, and it is understood that the other condition is that, and you execute that. Print it's not, it is an odd number. So let's see and execute. Now let me give my number, and it is an odd number. Yes, it is. And let us even check our even condition. Yes, so it changes according to your value you give. So our last decision making statement for today's video is going to be switch statement. So in switch you'll have number of cases, and when you enter your case and that particular output would be executed, or that particular code would be executed, as you can see in the flowchart. And if you don't enter it, the default case will be executed. So let us do the code for this, you'll understand it better. So I'll be doing the very basic code, which is performing, imagine it as a calculator with addition, subtraction, multiplication, division. So my header files and my math.h as well, because we'll be performing mathematical operations, and my main function, and I'll be giving my integers a and b, and I'll even assign values to them, as we might not be taking them. You can also take them or read them with scanf if you want. So let me assign the values. My A is 10 and B is 9. So let me take, for switch case, you'll have to take a choice from the user because it's in the user's hand to perform which case they want to choose. So let's give them the options also because they'll have to know the menu they have. And here we go. So we even take another variable C to enter the choice you want. So yeah, so it's going to be addition, and you'll have subtraction, multiplication, and division. And you'll also have to number them. I'll be numbering them later. Little mistake of codes here. Yeah, let me terminate it. Yep. And it's the same thing. And so I'm copying the text and pasting it. So it is going to be multiplication. And then we've got division. So this is the menu your user can choose from: addition, subtraction, multiplication, and division. And you have to take the choice from the user. So format specify %D and the choice with ampersand. Oh yeah, I have to number them. So 1 for addition, 2 for subtraction, 3 for multiplication, and 4 for division. Yep. And let us take our input choice ampersand C and terminate it. And now let's enter our switch statement. So we give switch and we give the choice you want to enter, as it's yeah, like this, exactly like this. And now we have got our case 1. So case 1 is addition. So you give, so let's declare another variable to store the value of our operation. So it's going to be s equal to a plus b, and printf your answer with format specifier and comma s, and terminate it. And in switch we give the case, we break it, we give the case and we break it. And this is how switch cases are going to work. So we got our case 2. Let me get them all to one side so it looks a little neat. And break. And our case 2 subtraction, so it's a minus b. Let's give our case 3. Break is quite important in the switch cases. So a star b, terminate it and print our output. And s, and terminate it and break again. Our very last case, case 4, which is division. So case 4, you can give anything. You can even give A, B, C as your choices, and you'll have to give case single quote A and close the quotes. So I've given numbers here, and because I've taken int here, you can give anything there and terminate it and break. So let's run the code. And here we go. I can choose anything. So let me choose addition. Yep, 10 plus 9 is 19, correct. So let's check with our default statement as well. So when you enter a value which is not in the menu, So you should get a statement which shows it's wrong. So for that you give default and printf invalid choice, and you don't use break for default case in switch statements. You can also choose to exit sometimes. So let me give 7 or any number which is not here. Yep, invalid choice, so it comes out. And let us check any other choice.